Hello guys, today I am going to show you how to do HVAC heat load calculation for the room G20. This is the E20 sheet guys, okay. This is the school building layout located at Bangalore. The false ceiling height is 10 feet and medium weight building equal to 80 lb per square feet. Today I am going to show you how to do heat load calculation for the room G20. The length of the classroom is 19.89. You can take it as 20, and width of the classroom is 17.65. You can take it as 18. Though, and the glass area is 5.9 by 4 feet. So you can take it 6 by 4 feet. And here glass is exposed to sunlight in the south direction. This south, this is north, this is west, and this side is east. Okay, so this is the E20 sheet, project school building, and area is G20, room size length 20 feet, width 18 feet, and area is 360 square feet, and false ceiling height is 10 feet. So volume is 3600 cubic feet. This latitude, altitude, daily range, and outside air I will show you from design data book. This is the outside design condition for Indian cities. So our location is Bangalore. So here Bangalore, the latitude is 12.6 and daily range is 22 and altitude is 921 feet. And for school building we have to take 93.2, 67.3. So suppose if it is a large buildings, so we have to take 91.6 and is a dry pulp and 66.6 is a wet pulp. Okay. Suppose if we have a small buildings, residential building, we have to take this 94.5 is a dry pulp and 67 point is a wet pulp. And for school building, I am going to take here 93.2 is a dry pulp and 67.3 is a wet pulp. Okay. So here latitude is 12.6. I put altitude 921. Daily range is 22. Outside air dry pulp is 93.2. Wet pulp is 67.3. With the help of these two values, we will get 27% is a relative humidity by psychometric chart or psychometric calculator, and humidity ratio is 64. Inside room we have to keep dry bulb is constant, dry bulb as a constant, which is 75, and relative humidity also constant, we have to keep 50. So with these two values, by using psychometric chart or psychometric calculator, we will get 63 is a wet pulp and humidity ratio is 65. So outside and inside the difference is coming. 18.2 is a dry pulp, wet pulp is 4.3, relative humidity is minus 23, and humidity ratio is minus 1. So this is done. Now I am going to show you solar gain through glass. Okay. This for reference, page reference, I put 8 by 29. No need to confuse. This is 8th page in design data book. So here our glass exposed to sunlight in the north direction. sorry, our glass exposure to sunlight in the south direction, we have to put the value in south direction. So glass area is 24 square feet. It is a mentioned in the drawing. 6 by 4 means 24 square feet. This solar factor is constant 0.78. Now I will show you how to take value solar gain value from design data book. This is the solar heat gain through ordinary glass. So our latitude is 12.2. So here 0 is there now. 10 and 20. See, our Bangalore latitude is 12.2, but here 12.2 is not there. Only 10 is there and 20 is there. So we have to go for higher value, that is 20 degree north latitude. We have to consider highest month, highest temperature month, that is July and May. And our glass is exposed to sunlight in the direction of south. So in the south we have to take highest value. Here south highest value is 14. So we have to take it as 14. Solar gain is 14 for south. Suppose if our glass is exposed to sun in the north direction, so north we have to take highest value is 28. 28 we have to take 28 as highest. For south we have to take 14 as highest, so 14 I will take. So here for south area solar gain is 14. If you multiply all these three values, you will get 262.08 V2 per hour. Okay, this is completed. Now outside air, you will get 360 automatically in E20 sheet. And people, I will show you from the furniture plan. It is 25 peoples. This I will show you CFM, how we got this value, CFM per person and CFM per square feet. Okay. This is the minimum ventilation rates in breathing zone. So our area is sorry guys. So our area is classroom from children from age 5 to 8. So we have to take CFM per person is 10 and CFM per feet square is 0.2. Okay. So if suppose it is a lecture classroom, we have to take this value 7.5 and 0.06. So our is a classroom. The age people age is from 5 to 8 years, and CFM percent is we have to take 10 and CFM per feet square we have to take 0.12. So here in classroom children are 25 people, CFM per person is 10 and CFM per square feet is 0.12. If you multiply all these values you will get this. So 293.2 CFM. And here transmission, now this is completed outside. Okay, now transmission gain through wall and roof. As we know, our wall is exposed to sunlight in the south direction. Okay, the south side area is, the width is 18 feet. So 18 into 13 we have to multiply by 2 height. 2 height is 13 feet. So you will get 234 feet. In 234 square feet we have to subtract 24 feet square feet glass area. So if you subtract 234 minus 25 you will get 210 square feet. Transmission gain 2 walls. Okay, because glass area we already calculated, we have to subtract from the wall area, this one. And U value and this one equivalent temperature difference I will show you from the design data book. So this is the equivalent temperature difference. So our wall is exposed to sunlight in the south direction. Okay, so our building weight is 80 lb per square feet, but here 80 is not there, only 60 is there, 100 is there. So what we have to do, we have to take the value from the 60 lb and 60 lb per square feet and 100 lb per square feet. If you take the average, you will get the value for the wall 80 lb per square feet. Okay, I will show you. See, in south 60 highest value is 26. You have to take below that only value 26, below is 16. 26 by 16 is 52. 52 divided by 2 is 21. So 21 is the equivalent temperature difference for 80 lb per square foot wall. Okay, 21. For this equivalent temperature difference, we have to add correction factors. Okay, one second, I will show. See, our temperature correction to equivalent temperature. This is one. See, our temperature difference is 18.2. So here 18.2, 18 is not there, 15 is there, above the 20 is there. We have to go for higher value 20. And our daily range, Bangalore daily range is 22. We have to intersect. We have to intersect 20 and 22. You will get the value 4. So correction factor is 4. So 21 plus 4 is 25. ETD value is 25. Oh, sorry. Okay, guys. See here, ETD is 25. And U value you will get from civil people. Otherwise, with the help of the standard book, we have to take U value, that is 0.089. Okay, I will show this one. Okay, I will show once again. So this is the standard U values, guys. Our is external wall. So for external wall, we have to take the U value 0.089. Okay. For roof, you have to take the value 0.063. It is constant. Actually, you have to get from civil people. Suppose if you not get any value from the civil people, you can take approximately this U value, guy. Okay. For partition, 0.487. For typical floor, 0.358 or 36 you can take. Okay. This is the U value standard, guys. Accordingly, I will put this U values in E20 sheet. So here U value 0.089. Okay, as per our standard. So multiply by these three values, you will get 467.25. Okay, and here our roof is not exposed to sunlight because above there is a first floor, so it is, you put 0 here, leave it as it is. Okay, so transmission gain wall to walls and roof, it is completed. Now infiltration. It will get, you will get the value automatically, guys. This 3600 cubic feet. This 0.25 exchange per hour. I will show you. Our wall is exposed to sun in only one direction, so exposed to wall is, for summer we have to take 0.25. If our wall is exposed to sun in two directions, it will take 0.5. Okay, if wall is exposed in three directions, you have to take 0.75. Okay, so our wall is exposed to sun in only one direction, so it is 0.25. So we get 0.25. If you multiply, you will get net outside air is 278.2. Okay. So now transmission gain through other. So hourglasses it will come automatically the value rate, and temperature difference is 18.2. 18.2, and here non-AC partition glass, here nothing is there, and non-AC partitions. Now non-AC partitions and non-AC flow. Non-AC flow is here 360 because below our flow is ground floor, because there is a non-AC partition, so it is considered as a non-AC flow. It is 360. Okay. And temperature difference is here outside is temperature 18.2. We have to subtract -5 for everything. 18.2 minus 5 13.2, 18.2 minus 5 13.2, 13.2. It will take automatically value. Means there is a outside and inside there is a 5 degrees difference, guy. Okay. For example, if you take 20, you will get 50 like that. It's 18.2, so you'll get 13.2. Okay. Now I will show you non-AC partitions. How it come non-AC partition. Okay. And U values, as I showed you before, you have to take from civil people. Otherwise, you can take from standard book. And for glasses U value, I will show. And this non-AC partition. First, I will show this non-AC partition. See, this is our plan. So this area is already we calculated. This area, next to this area is a AC room. So actually we are calculating for non-AC partition area. So here there is a no AC, so we have to calculate this area value. And here also not AC, non-AC partition. So we have to calculate this value, non-AC partition. Okay. So here 18 is there. So 18 into, we have to multiply by 2 height, that is 13. So you will get 234 square feet, and here 20 into multiply by 13, you will get 260 square feet. So if we add these two values, you will get 494 square feet, guys. Okay. So non-AC partition 494 square feet, temperature difference 13.2, U value from standards 0.48, so you will get these values. Okay. Non-AC flows is 360 and temperature difference is 13.2, U value 0.36, so you will get this value. Now infiltration and outside air. You need not to do anything, you will get automatically. Infiltration we already calculated, you will get 15 CFM, temperature difference is 18.2, and this conversion point factor 1.08, you will get this one. And this bypass outside air, CFM you get 278.2, temperature difference is 8.2, and balance factor is 0.1, and conversion factor is 1.08. So you will get 546.82. Okay. So infiltration and outside air is completed. Now internal heat. Here people, as we know, in the classroom 25 people are there. Okay. Now I will show how to take sensible heat and latent heat from the data book. One second. See, this is a design data book. So sensible heat we have to, and latent heat we have to take from heat get from people. Okay, here office you have to take office, hotel, apartment. We have to take this sensible heat is 245 B2 per hour and latent is heat is 155 B2 per hour. Okay, actually our is this one classroom, but here is classroom is not there, so you have to take this value. Office, hotel, apartments, 245 sensible heat and latent heat is 155. So here sensible heat factor is 245. Okay, and lights, I will show lights. And appliance, approximately you have to take 1000. Actually you will get from electrical people, otherwise you take approximately 1000 for classroom. And this is ballistic factor, these are constant values. So this is the lighting power densities. Ours is classroom, so you have to take 1.4 watt per feet square, and we have to multiply this with our area. 1.4 into 1.4 into our area is 360, so you will get 504. Okay, see here 1.4 into our area 360, so you will get 504. These constant factors, ballistic factor is 1.25 and conversion factor is 3.41. It remains constant. One second, this conversion factor is means converting CFM into BTU. Okay, this conversion factor is because of converting CFM into BTU, so you will get this value. And appliance you have to take from electrical department, otherwise you can approximately put for classroom 1000 watts. This is the usage factor, this 0.75 will remain constant, this conversion factor 3.41, so you will get these values. Okay, here nothing is there, miscellaneous we don't have anything. Okay, so this is sensibility is done. So total room sensible heat is 17736.088. Okay, and we have to add safety factor, so you will get effective room sensible heat is 19509.6967. Okay guys, so this is finished. Now latent heat, here people automatically count 25, and B2 is for latent is we calculated from data book, we took 155. Okay, so we get 3875, it will come automatically. Infiltration we already calculated, it is 15, and this is the humidity ratio difference. Our humidity ratio difference is -1, so -1. This conversion factor, this remain constant, so you will get this value. And bypassed outside area is 278.2. Here bypassed outside area is 278.2, and humidity ratio difference is -1, conversion factor is 0.68, and bypass factor is 0.1, so you will get this value. So you will get total latent heat equal to 3845.8824. Okay, and effective latent heat is 4115.09417. These are safety value you will get automatically from E20 sheet. Okay, and effective total heat is 23624.7809. Okay guys, this one finished. Now outside air heat, sensible heat This is 278.2. 1 second. Yes, means sensible heat bypass outside egg 278.2. Temperature difference is outside temperature difference is 18.2. So conversion factor 1.08. 1 minus balancing factor you will get 0.09. So we will get this value. And latent heat, this outside at 278.2. This is grain difference, humidity ratio difference -1. So conversion factor 0.68. This 1 minus balancing factor you will get 0.9. So this value you get. So effective outside is it is equal to 4988.77142. Okay guys, and here you will get 2.3845 tonnage, approximately 2.4 ton. Okay, and here effective sensible heat factor equal to this one. Once again, effective room sensible heat, that is 19509.6967 divided by effective room total heat 236.24.8. So we'll get this value. Okay, now once again, okay, now I will show how to take ADP. How to select where to ADP. Okay, Apparatus due project. See here, this is the apparatus dew point. Okay, so we have to check our dry bulb temperature is, it is 75 and relative humidity is 50. We have to check in this area. 1 second, I will zoom it. Okay, is 75 dry bulb temperature and our relative humidity is 50 inside the room. Inside the room relative humidity is 50 as 50. It is constant. Okay, 75 and 50 here. We have to check this, and our effective sensitive heat factor is 0.82. We have to check here. So here 0.78 is there, 0.84 is there, so 0.82 is not there. Okay, so we have to go for higher value, means we have to take for 0.84 52. So we have to take 52 as a apparatus dew point. Okay, so our apparatus dew point is 52. Okay guys, so this completes our HVAC heat load calculation. Okay guys, if you like this video, please share and subscribe. Okay, thank you guys.